Section 4.5 is all about graphs of other trig functions. So we'll talk about tangent, secant, cosecant, and cotangent. So let's start with tangent. Tangent theta is y over x, which is sine theta over cosine theta. Tangent is slope. If a non-vertical line makes an angle theta with the positive x-axis, then the slope m of the line is given by m equal to tangent theta. Please take a look at an example posted in the Canvas notes of an example with like y equals mx plus b. Given a point and given an angle, you can find the equation of a line. Let's next talk about domain and range. The domain of the tangent function is going to be all real numbers except where the denominator is 0, in this case, where cosine is equal to 0. So our domain is going to be all real numbers except when x is plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, etc. Now the range of the tangent function is negative infinity to positive infinity. The zeros of the tangent function, or in other words, the x-intercepts, happen when my numerator is set equal to 0, so where sine x is equal to 0. That happens when x is 0, pi, 2 pi, etc. So at x equals n pi. Now the period of a tangent function is actually pi, which is different than sine and cosine, which have period of 2 pi. So please be careful. Tangent, again, has period of pi. Even odd property, y equals tan x, is an odd function, and therefore it is symmetric about the origin. Because our tan function is a fraction and we can't have 0 in the denominator, that indicates our graph will have vertical asymptotes. And it will be at odd integer multiples of pi over 2. So you can take a look at the graph. I drew just one cycle. I have vertical asymptotes at negative pi over 2 and positive pi over 2. And the graph kind of looks like an x cubed squiggle of what the shape looks like for tan x. Now, there's a 4-step process of graphing the tangent function. The equation looks just like it did before for sine and cosine. We have y equals a times tangent b times x minus c plus d. Again, making sure that inside stuff is in factored form. It follows really closely to sine and cosine, but we have a few differences, a few terminology changes. Excuse me. Step 1. Vertical stretch factor. So you notice the shape of a graph isn't a wave, so it doesn't have an amplitude, but instead we go back to using the phrase vertical stretch. So the vertical stretch is the absolute value of a. The equation for a period this time for tangent is pi over b. Again, don't get that confused with the sine and cosine equation, which is 2 pi over b. So tangent is just plain pi over b. Phase shift stays the same, it's c. Again, depending if it's moving right or left. If it's negative, it's moving to the right, and we use the positive c value. If it's positive in the equation and it's moving left, then we're going to say negative c. Vertical shift stays the same, up and down. If it's positive, it's shifting up. If it's negative, it means it's shifting down. Now, step 2 kind of has a similar approach to sine and cosine. We want to know where our graph starts and ends one cycle, but the starting and the ending for a tangent graph are going to be considered a vertical asymptote. So step 2 is to find the two VAs. You do that by taking that inside stuff, b times x minus c, and setting it equal to the original two vertical asymptotes, which is going to be negative pi over 2 and positive pi over 2, and then solve for x, and that will be the location of your two VAs. Step 3, again, very similar, just 1/4 times the period. Again, we're kind of looking for those 5 key points. But if you think about it, if we have our 5 key points, that first key point and that last key point are actually your vertical asymptotes. So when we go and really do our XY chart in step 4, you only need to calculate 3 points, and those are the 3 middle key points. You can do the calculation for key point 1 and 5, but you'll get undefined, meaning you'll have a vertical asymptote. So your XY chart, again, is only going to have 3 x values and 3 y values that I'll require you to show me. And then, of course, you're going to sketch in step 4. In the next video, I'll go through a full example of graphing a tangent function. Next, though, I want to take a look at the graphs of the reciprocal functions. Let's start with y equals cosecant x. That is equivalent to saying 1 over sine. Again, we have a fraction, so my domain is going to be all real numbers except what makes my denominator 0, and x cannot be equal to n pi. The range of cosecant goes from negative infinity to negative 1, union 1 to infinity, again, assuming no shifting of the graph just yet. The period for cosecant will be the same as what sine was. The period is 2 pi. The graph of the reciprocal function has no x-intercepts, so cosecant does not have any x-intercepts. Again, this is an odd function. And because the function has a denominator, that means my graph is going to have vertical asymptotes. And my vertical asymptotes will happen at x equals n pi. So the way you graph the reciprocal function of cosecant is you actually start by graphing sine x. So I went ahead and graphed sine x, and then I'm going to put the pieces together for what cosecant actually looks like. So again, cosecant, I can't have a 0 in the denominator, so everywhere I see a 0 in my sine graph, so here at 0, pi, and 2 pi, I actually have vertical asymptotes. So I'm going to have a VA at 0, pi, and 2 pi. And then the actual shape of cosecant is starting at the peaks. It kind of just makes a shape that looks like a parabola that goes up or down towards the asymptotes. So the curves in red are actually the graph of cosecant. So really the trick for graphing is you graph the sine function, and then everywhere you have a 0, that's where your vertical asymptote is going to go, and then you just draw parabolas off your curve. Alright, it's going to be pretty much the same thing for secant, but I'll quickly go through that. So y equals secant x is equal to 1 over cosine x. So the domain is going to be all real numbers except where the denominator is 0, right? So that happens this time at pi over 2 plus n pi. Again, my range, negative infinity to negative 1, union 1 to infinity. Again, my period is 2 pi. There'll be no x-intercepts. We will again have vertical asymptotes, this time at x equals pi over 2 plus n pi. So here again is my cosine graph. The trick again is everywhere I have a 0, I'm going to go ahead and draw a vertical asymptote. And then again, I'm going to have parabolas that come off my peaks. Now, drawing just one cycle looks a little goofy. Remember, this is periodic, so this will keep on going, right? These will really look like parabolas going up and down with vertical asymptotes. All right, last but not least, let's talk about cotangent. Again, cotangent is 1 over tangent, which is also equal to cosine over sine. The domain is going to be all real numbers except where x is equal to n pi. Our range is negative infinity to infinity. Again, take note, this time our period is pi, the same as what was for tangent. All right, I do have x-intercepts, again, where my numerator is equal to 0, so that happens at pi over 2 plus n pi. Again, an odd function, and my vertical asymptotes happen at n pi, and I went ahead and pre-drew this out for you. So again, you have vertical asymptotes at 0, pi, 2 pi, etc. Your x-intercepts at pi over 2, 3 pi over 2, etc. And so this time the shape of a curve kind of looks like x cubed but flipped. So a little downward snake spiral action happening there.